So binomial distribution formula is, see, you can check in your past papers, they have given to you like definition or concept also, or they have given to you only questions, like numeric questions.
Numeric questions, ma'am. Theory questions will be there will be like 10 questions, ma'am, of 2 marks each. And I'll be
Theoretical
having
question.
ma'am, I'll be having both, ma'am. Theory I'll be having for 20 marks, 2 marks questions, 10 questions.
Okay, so you
And
can
I'll be
send me a
and
past paper so that I can understand, and we'll give you
I'll
theory
send it to
question.
you by tonight, ma'am.
Yeah, so that I can
Yes, ma'am.
prepare a theory for you and will explain you one day, okay? After finishing
Sure,
this.
ma'am, sure. Sure.
So binomial distribution formula is
Yes.
P x is equal to small x, or in some material they can give you like this px. Like
Yes,
we
ma'am. Yes.
find probability, okay,
Hmm.
for, when we have large number of toss or trials, okay.
Yes, ma'am.
So
Yes.
this small x represent value of random variable, like we have taken yesterday 0, 1, 2. So these values represented by the small x, okay, value of random variable is equal to n c x p to the power x and q to the power n minus x. Now let us understand these terms. What are they? And then we will do a question. Where n is equal to number of trials or number of experiments, or number of like if we need to find if a coin toss 1,000 times, then we can say there are 1,000 trials, okay, or 1,000 experiment also, where n is the number of trials or experiment. X small x is equal to value of random variable. So we can take value of x as 0, 1, 2, and up to. Hello?
Am I audible, ma'am?
Yes.
So, ma'am, the light went off, ma'am. Yes, ma'am.
Okay. So, where you left,
Yes, ma'am.
because I didn't get, you got this formula.
Yes, ma'am.
So, here I'm telling you what are these terms.
Yes, ma'am.
And x, value of random variable. And we can take value of x as 0, like for 0 hat, for 1 hat, for 2, and up to so on. P is equal to, small p is equal to probability
Yes.
of success in one trial. Like if we want to find number of hats, probability, or like in 1,000 toss, we need to find 700 hats, right? Then small x will be 700. Okay. And probability of success
Okay.
in one trial will be 1/2, because when we toss a coin once, then probability to
Yes,
get
ma'am.
hat is 1/2. Are you getting me?
Yes, ma'am.
Yes.
Yes, ma'am. Yes, ma'am.
And Q is probability of failure. And like if you
Okay.
want to find hat, then probability of to find tail is probability of failure. Okay.
Yes, ma'am.
Small q is equal to probability of failure. And we can find q is equal to 1 minus p, small p. Okay. This is the formula of binomial distribution. You got it?
Yes, ma'am.
Now let us do one question to understand this well. I'm sending you that question and we will do in class.
Okay,
And
ma'am.
after that, we
Yes,
will
ma'am.
do Poisson distribution, then normal distribution.
Okay, ma'am.
Send your question. Okay, let's do. So coin is tossed 5 times. Then probability of, we need to find exactly 2 hats and at least 4 hats. So let us do this question. So here n is equal to 5 toss. So we will take it as 5. Okay, toss.
Yes, ma'am.
Number of toss we have 5. So n is equal to 5. And small p is equal to probability of success in one trial is 1/2. You got? And q is equal to 1 minus p. This will be also 1/2. And now in first part, for exactly 2 hats, then we will take x is equal to 2. So now we need to find probability to get 2 hats in 5 toss. So let us find.
Okay.
P capital
Okay.
X is equal to small x is equal to, formula is this, NC x, and P to the power x, Q to the power n minus x. This is combination. We will use here combination formula. I'm telling you what is it, okay?
Yes, ma'am.
Yes, this is combination form. They'll allow you calculator also, so you can find directly, right? Calculator is allowed
Sorry,
in
ma'am.
in stats. They allow calculator also.
Yes, ma'am. Yes, ma'am.
Yeah.
Yellow
So
calculator.
you can find easily with calculator, but right now I'm telling you by using this formula. Okay, NCX. What is it? So N formula is NCR is equal to factorial N over factorial. Do you know factorial value?
Sorry, ma'am.
Do you know this factorial value?
This factorial value. No, ma'am.
Okay, I'm telling you. Factorial
Yes, ma'am.
value, if we talk about factorial 4, it means we multiply 4 into 3 into 2 into 1. Okay, it will be
Okay.
26. If we talk about factorial 3, then we will multiply 3 into 2 into 1. Okay, we will get 6. Now
Yes,
you
ma'am.
got this is
Yes, ma'am.
factorial 4, this is factorial 3. Like multiply the
Got it.
number and rest of like first of all we'll take 4, then 3, then 2 in 1 and multiply all of them. Similarly, you can find any factorial value. Like I'm telling you factorial 5. Factorial 5 is equal to 5 into 4 into 3 into 2 into 1. So you will have 120. But you can use this form directly by using calculator. So we can take
Okay, ma'am.
directly also, okay? We use this
Yes, ma'am.
formula because this is different topic, but we use here. So
Okay.
here and instead of n, we will take because p x is equal to 2. Why? Because small x is 2. So we are taking here
Yes, ma'am.
and n is 5 and c and 2 because x is 2. P is 1 by 2 to the power 2 because small x is 2 into q is also 1 by 2 and to the power 5 minus 2. Are you getting me?
Yes, ma'am.
And let us simplify this 5 c2, okay, by using formula.
Okay. Yes, ma'am.
By using this formula.
Hmm.
5c3. We will take in numerator factorial 5
Okay.
and here we will take factorial 3 in bracket 5 minus 3 factorial. So we have factorial 5 over factorial 3 into factorial 2. So now let us find its value. Factorial 5 will be 5 into 4 into 3 into 2 into 1. And factorial 3 will be 3 into 2 into 1. And factorial 2 will
Yes,
be
ma'am.
2 into 1.
Yes,
So
ma'am.
we can cancel 3 with 3 and this 2 with 2 and this 2 will cancel this. So we will get 10.
Yes,
5
ma'am.
to the you got.
Yes, ma'am.
So let us put here
Hmm.
10.
Okay.
By using calculator, you can find directly also with this 10. Okay.
Yes, ma'am. Yes, ma'am.
10 and into 1 by 2 to the power 2. And here we will get 1 by 2 to the power 3.
Yes, ma'am.
See, when we have same base is 1 by 2, then we can add powers. We can add powers. When we have same
Okay.
base in multiplication, because we are multiplying here, okay, then we can add
Hmm. Yes.
powers. So let us
Okay.
add them. 2 plus 3, 10 into 2 to the power 1 by 2 to the power 5. Let us simplify. If you will use calculator to find 1 by 2 to the power 5, you will have 1 by 32. Oh, you will have this 10 by 32, or you will get 5 by 16. This will be x equal to 2. This is probability to get exactly 2 hats in 5 toss. You got?
Oh, yes, ma'am.
Now we will find at least 4 hats. At least means have 4 and more. See, according to
Okay.
number of trials, we can get number of hats. Like in 2 trials, we can get maximum 2 hats. In 3 trials, we can get
Hmm.
maximum 3 hats. And in 4 trials, we can get maximum. And here we have 5 tossed. So we can get
Hmm.
maximum 5 hats. So
Yes, ma'am.
they have given to us at least 4 hats. It means 4 and more than 4. So more than one value we have maximum till to 5.
Yes, ma'am.
So let us do B part. here x is equal to greater than or equal to 4. So
Okay.
Px is greater than or equal to 4. It means we can find x is equal for x is equal to 4, and maximum we have x is equal to 5 because we can't have number of hats greater than number of toss.
Yes, ma'am.
We can get maximum 5 hats in 5 toss.
Okay.
Okay. So now let us find
Yes, ma'am.
probability. Now let us find these values. Okay.
Yes, ma'am.
So P at x is equal to 4. We will have here 5C4, 1 by 2 to the power 4 and 1 by 2 to the power 5 minus 4. So let us find
Okay.
here 5C4. 5C4 is equal to factorial 5 over factorial 4 into 5 minus 4 factorial. So 5 factorial, 4 factorial into 1 factorial. So let us expand this factorial value.
Okay.
5 into 4 into 3 into 2 into 1 or 4 into 3 into 2
3
into
into
1 and
2
2
into
factorial value of factorial 1. So let us cancel
okay.
whatever we can. So we have 5. So
5.
5C4 is
Hmm.
5. Write down here 5
Yes.
and here 1 by 2 to the power 4 into 1 by 2 to the power 1. So in multiplication, let us add the powers when we have same ways 4 plus 1. So here we have 5 into 1 by 2 to the power 5. So 5 upon 32 because 1 by 2 to the power 5 means 32 in numerator, denominator, sorry. Got it? This
Yes,
is
ma'am. Got
for
it, ma'am.
x is equal to 4. Now let us find for x is equal to 5 also, then we will add. For
Yes, ma'am.
x is equal to 5, this will be 5C5. When we have same number here and here, then its value will be 1. Okay, always. When you have same number here and here, then you have 1. And 1 by 2 to the power 5 into 1 by 2 to the power 5 minus 5. So its value is 1 and its value is 1 by 32 and its value will be 0. If any number has value 0, then its value will be 1. Its power is 0. So 1 by 32. Now let us find probability to get at least 4 hats. For at least 4 hat, we use this inequality symbol. We have x is equal to 4 and plus x is equal to 5. So it is 5 by 32 plus 1 by 32. So we have 6 by 32. Sorry, 32, not 36. So we will have 3 by 16. Okay,
Yes, ma'am.
you got? So they'll
Got
give
it,
you
ma'am.
number of trials and will ask you for any value of x. Then you can use binomial distribution and can find the probability. You got each and every step?
Yes, ma'am. Got it, ma'am.
Okay, that's good. So now let us do Poisson distribution. Is that okay with you?
Yes, ma'am. No issues.
Okay. Just few seconds. I'm opening my material. See, in previous distribution, we will have two condition, either for success or for failure, like tossing a coin. Okay, they can give you a
Hmm.
condition of success and failure also. Then we use binomial
Yes, ma'am.
distribution. Okay, and if they'll give
Okay.
you like average rate of something, and you need to find probability, then you will use
Okay.
Poisson distribution. Okay,
Yes.
so its formula is Px is equal to small x, or they can give you like this px only, also like this. Okay, meaning
Yes.
is small x represent value of capital X is equal to e to the power minus lambda, lambda to the power x, and over factorial x. And where e to the power lambda is exponential function of lambda. Lambda is average rate of value. They'll give you, okay, in exam. Whenever you have this
Yes.
average rate of something, then you will use this Poisson distribution. Lambda is an average rate of value. And X is a Poisson random variable. Even they'll mention by using Poisson, or they can say you if X is Poisson random variable, or they can mention by using Poisson distribution. But sometimes, rarely they'll give you like without using these words. Rarely. Then if they'll
Yes,
give
ma'am.
given you an average rate, then you will understand that we need to use Poisson distribution. Okay.
Okay. Okay, ma'am.
So let us do one question to understand this.
Yes, ma'am.
See, I've sent you question. Let us do now.
Yes, ma'am.
So, in this question, they have given to us the condition. Here, p x is equal to 1 is equal to 0.2 times of p
Okay.
x is equal to 2.
Yes.
So, let us do this question. P x is equal to 1 is equal to 0.2 p x is equal to 2. So let us use formula on both sides. So its formula will be e to the power minus lambda 1 to the power.
Okay.
See, we are using formula. So sorry, lambda to the power 1. Lambda to the power 1 because x is 1 and over factorial 1 is equal to 0.2 e to the power minus lambda, lambda to the power 2 because we are using x is equal to 2 and factorial 2. Then we can cancel this e to the power lambda on both sides, e to the power minus lambda on both sides. Are you getting me? Because we
Yes,
have,
ma'am.
yeah. So rest of we have lambda over factorial 1 is 1. Okay. So we can take it as
Okay.
is
Okay.
equal to 0.2 into lambda square over factorial 2 is this 2 into 1. So we can write 0.2 into lambda square is equal to 2 lambda 1 because we can multiply using cross multiplication. Are you getting me?
Yes, ma'am.
Now, uh, let us divide. We can cancel one of its power. Do you know when we have same number having different power, then we can cancel here lambda to the power 1. Okay. So
Yes, ma'am.
we can take it as lambda square over lambda is equal to 2 over 0.2. You got? By using cross
Yes.
multiplication, we took lambda here and took this 0.2 here.
Okay.
So lambda is equal to 10 times. We can cancel it. So lambda is equal to 10 we have. Okay. Now we can find this probability because they have given to you us find p x is equal to 0 means we need to find probability at x is equal to 0. See in question
Yes.
they didn't give us value of lambda. They have given to us a relation. Okay, by using that we need to find lambda. See, we have given to us this relation. By using that we found value of lambda as. Now we can find probability at x is equal to 0. Let us find it.
Yes.
Is equal to e to the power minus 10 because lambda is 10 into lambda to the power 0 because in formula we have lambda to the power x. So x is 0 and factorial 0 and factorial 0 is equal to 1 and factorial 1 is equal to also. Got it? So now
Yes, ma'am. Got it, ma'am. Mm.
e to the power minus 10 and any value to the power 0 then its value will be 1. So it is 1 and
Okay.
factorial 0 is also 1. So we have this e to the power minus 10. Okay, by using
Yes.
calculator to find this value, then you will find by using calculator's value 0.0000454. Okay.
Yes, ma'am.
So now you got how can we find question by using Poisson distribution? Either they'll give
Okay.
you most probably they'll give you average rate of value. Okay, most probably. Rarely they can give you
Yes, ma'am.
like this relation. That is why I have taken this question because in rare case you have this type of question, then you can find value of lambda easily. Then can put value of lambda in formula. Okay, in this formula
Yes, ma'am.
and can find the probability. Got it?
Sure, ma'am. Yes, ma'am. Got it, ma'am.
Now, shall we do the normal distribution?
Yes, ma'am.
Normal distribution. Its formula is fx is equal to 1 upon square root of 2 pi sigma square into e to the power minus in bracket x minus mu whole square over 2 sigma square. They'll give you these values. Okay. Here I'm telling you
Yes,
what
ma'am.
are these.
Yes, ma'am.
So where mu is equal to mean, they'll give you in question. Okay.
Yes,
Sigma
ma'am.
square is variance and only sigma is standard deviation. They can give you sigma also. Okay. Standard deviation.
Yes, ma'am.
And small x is normal random variable because this is normal distribution. So here x is normal random variable. Okay. So let us do one question to understand this.
Yes, ma'am.
I have sent you question. Let us do now.
Yes, ma'am.
In question, find the probability density function. This fx is said to be probability. This fx is said to be probability density function. Probability density function fx. Okay, this is.
Yes, ma'am. Yes, ma'am.
So they asked us find the probability density function for the normal distribution where mean is 4, standard deviation is 2 and x is equal to 3. So in this question they have given to us given that mean mu is equal to 4. Standard deviation sigma is equal to 2 and x is equal to 3. So let us put these all values in normal distribution formula here. Okay, let us put.
Yes, ma'am.
So fx probability density function is equal to 1 upon square root of 2 pi into 2 square like we have here